Okay, so we are doing the last section of chapter 7, and this is actually combining back to chapter 5. And in chapter 5, we talked about the special segments of triangles. So if you remember, we talked about altitudes, medians, angle bisectors, and perpendicular bisectors. Okay, so we're actually connecting to 3 of those special segments today. Okay. The one that we're not doing is perpendicular bisector. And if you can remember, the only difference between, well, not the only, but the difference between a perpendicular bisector and all 3 of the other special segments is that the perpendicular bisector did not have to come from the vertex of that triangle. Okay. So what we're doing is we're seeing the proportions that these special segments make. Okay. So like I've done in the past, I have the definitions already written out. All right. So make sure you pause if you need to. All right. Because I'm just going to read through them. So theorem 7.8 says the ratio of corresponding altitudes, all right, of similar triangles is equal to the scale factor. So what we're essentially saying is that it's proportional to the scale factor. Okay. Now, if we remember what an altitude is, and that's what I'm going to draw in this picture section, I'm going to draw just a regular triangle, okay? And if you remember what the altitude is it's the perpendicular segment connecting a vertex with the opposite side, okay? So this right here, this perpendicular segment is my altitude, all right? So if you look at example 1, it says, what can you conclude if triangle ABC is similar to triangle EFG? All right, now there's some information that I need to tell you guys first. So I'm telling you guys that BD and FH are altitudes. So let's go ahead and mark, all right, that this is a right angle and that this is a right angle, okay? All right, so remember what we have to do is we're actually going to find our scale factor first, okay? And in order to figure out what sides correspond with one another, we have to use our similarity statement, okay? So I'm going to just start off with saying, all right, well, I know AB is to EF, and that's going to be my scale factor. So AB is to EF. And what this theorem is saying is that the altitudes are proportional to that, right? That the ratio of the altitudes is the same. So because I started with AB, so in this triangle right here, all right, I'm going to have to pick the altitude of that triangle to match up with AB. So I'm going to have BD up here. And then with this triangle of FEG, all right, the altitude is FH. And there's my proportion. So AB over EF is equal to BD over FH. Okay, not bad. And for the next 2 theorems, it's going to be very similar to this. Okay, so for theorem 7.9, this one says that the ratio of corresponding angle bisectors of similar triangles is equal to the scale factor. Same exact idea. Okay, now if we go ahead and draw, all right, a triangle, let's just remember what an angle bisector is. All right, so I want to bisect that top angle, all right? So I'm going to draw an angle bisector. So what does it do? All right, well, what an angle bisector does is it splits this angle into 2 congruent angles, okay? All right, so we know that triangle ABC is similar to triangle EFG. Let's go ahead and mark, all right, our angle bisectors. So I'm telling you, all right, that BD is congruent to, angle ABD is congruent to angle DBC, all right? And I want you to look at my notation here. Angle FEH is congruent to angle HEG. So my question is that notation okay? That I'm saying that all 4 of these angles are congruent? Well, I need to change something here, guys. Okay, sorry, my similarity statement is not correct. All right, so in this one, I need it to be FEG. Okay, so I have to have FEG. So what that means is, all right, that angle B and angle E are corresponding angles. And what do we know about corresponding angles within similar triangles? Well, we know that they are congruent, all right, and if we're bisecting the angle, then all 4 of these angles have to be the same. So same idea, all right, we're going to find our scale factor, and we are going to take AB over FE is equal to, all right, our 2 angle bisectors, so BD over EH. H. Okay? All right, I'm going to pause there and then come back with the last two theorems.